Hi everyone. Data science is the current hotness. While those of us in these virtual rooms may make fun of the likes of Dominic Cummings for extolling a data-driven approach to policy, the reality is that data science as a buzzword bingo term has survived and indeed thrived in a climate where artificial intelligence is increasingly derided as being something that's more written in PowerPoint than Python, and machine learning still gives people images of liquid metal exoskeletons crushing powdery, puny human skulls, and those in management with long memories remember what kind of mess quantitative analysis got us into not too long ago. Way back in 2012, the Harvard Business Review described data science as the sexiest job of the 21st century. And since then, we've been appearing in job specs and LinkedIn posts and research funding applications and business startup perspective more than ever. You're not really doing tech unless you've got a few data scientists under your wing. Like some kind of mythical creature, these data scientists sit somewhere between wizards and artificers and necromancers, breathing business intelligence into glass and copper to give the appearance of wisdom from a veritable onslaught of data, wielding swords of statistical t-tests, shields made of areas under curves, and casting magics of recurrent neural networks. Like if Tony Stark and Stephen Strange fell into a blender and the Iron Mage appeared, extracting wisdom from the seen and unseen worlds around them and projecting wisdom into the future. Or something more like this. However, for an organization attempting to leverage these mythical data scientists, how do you introduce and accommodate and indeed welcome these new skills into your production culture and ecosystem? In this talk, we'll walk through some of the philosophies that I've arrived at as someone who started off as a lone data scientist, now transitioning to team leadership, and what tools I recommend to new hires and intrigue colleagues to understand complex production architectures. So generally, what I wish I knew whenever I started with modern-ish data science workflows. Also, a couple of dodgy stories from over the past couple of years of data science gone wrong that will probably get some questions asked, and hopefully not of me. But this isn't going to be a technical data science talk. We're not opening up Jupyter or firing up Spark or TensorFlow or whatever. We're not even talking about perceptrons or distributions or anything like that. This is about people, process, and how to establish a healthy data science culture. But who am I to talk about any of this stuff? My professional background, such as it is, started off by getting robotic dogs to headmasters in front of 200 primary school kids, generally taking things apart and always having a few screws left over or loose at the end. I eventually turned that skill set into something of a trade by studying electronics and software engineering at Queen's. As part of this, I got to test the launch of 4G networks in China from the grey comfort of an office in Athlone. I moonlit as a technology consultant for marketing and advertising firms in Belfast, used massive clusters of GPUs to optimize cable delivery, cable internet delivery, and spent a summer developing BIOSes for embedded computers in Switzerland. After that, and just in time for a global financial crisis, to make everyone question their career choices, I continued down the academic culvert to do a PhD, stealing shamelessly from the sociologists to make their science vaguely useful by teaching autonomous military vehicles, military submarines, how to trust each other. More recently, I worked with a bunch of psychologists and marketers to teach machines how to understand human emotions using biometrics and wearable tech as the only data scientist. This being a small startup, that meant that I did anything that involved data. So from storage and network administration, statistical analysis, real-time cloud architecture, academic writing, and everything in between. This also somehow involved throwing people down mountains and developing lie-detecting underwear. The joys of startups. After that, I got to be a grown-up data scientist working in a cybersecurity firm specializing in real-time network intrusion detection systems, playing with terabytes of historical and real-time data, trying to read the minds of hackers and script kiddies across the world who are throwing everything they can at some of the internet's biggest institutions. This was my first taste of being a data scientist who wasn't working completely alone. After 2 years in that role, I got pinched to build a new data science team within an established security group called White Hat Security, and they'd recently been acquired by NTT as a global conglomerate. They've got about 15 years of human expert trained data on if and how customer websites can be vulnerable to attack. We've got teams of people working 24/7 to try and break people's websites before the bad guys do, to prove that they're vulnerable, and one way or another we have those footprints of investigation, and the company wanted to start doing something with that data, so they needed a data science team. I've been there a year, and this isn't a sponsored talk, so I won't rant too much about it, but all I'll say is I'm still really enjoying the work. Anyway, with all that in mind, I want to look at this. How do you spin up data science from three perspectives? First off, things that made data science a pain in the ass for me. Secondly, methods and approaches that I as an individual contributor came up with to make my own life easier. And now that I'm leading a team, how am I trying to put those approaches into practice and hopefully soliciting helpful, constructive advice from you lot as well. But what is a data scientist really? For a change, and with a certain sense of irony, Google itself has settled on a pretty decent job description for the field. A person employed to analyze and interpret complex digital data, especially in order to assist a business in its decision making. To me, this definition encapsulates three of what I think are the four key elements of what the modern data science role is, and it's all the sexy ones that everyone gets the first time around. What we're talking about here is the interplay between data complexity, business context, and assistive communication. The obvious one is the complex data. You need to be able to access, manipulate, and understand structured and unstructured data stores. You need to know how to navigate and validate your assumptions about that data and different techniques and methodologies to abstract, compare, and visualize that data to derive insight. Very common second highlight is that communications aspect. At the end of the day, it's your job to inform your internal and external customers with an appropriate amount of actionable information so that they can make an informed decision. And more subtly than that, you need to be aware of what the business as a whole is trying to accomplish, not just the direct requirements that may be foisted on you. Some people call this systems thinking. I call it caring about other people's work as well as your own, but each to their own. As we'll see later, this is often more important on the interpreting side of things than on the communication side. So we have Google's defined trifecta of complexity, communications, and context, and I'd like to add in some more, but one more. I think it's quite overlooked in many ways, but in the interests of not breaking anyone's brains, we're going to forego the Venn diagrams in favor of bullets. So what's this fourth thing? It's continuity, and yes, it is a bit of an alliterative backronym. But when I say continuity, I mean many things, or it has many meanings in my perspective. Continuity of operations through automation and continuous testing, continuity of visibility enforced by the construction of reproducible reporting and continuous dashboards, continuity of meaning by the explicit and near obsessive transparency of recording and sharing our assumptions, decisions, experiments, and most importantly, failures. Continuity of operations by continuity of operations by operating under the assumption that your data science capability could actually survive your team being hit by a bus. So in my contrived setup, we've now got complexity, context, communication, and continuity. Great. After 10 minutes, we've got a definition-ish. Great. Move on. What does this all mean for someone either getting into the data sciences as a career or building out a new capability? Before we get into the solutions, I'd like to just quickly share a couple of what that I've come across in my career and then spend a little bit of time explaining where those actually came from. I'll avoid naming names to protect the guilty, but here's a few buttes in no particular order. First off, Exhibit A, the thing table. Once upon a time, a bright-eyed data scientist was exploring a database. This was a mixed Perl PHP environment that had a lot of business logic embedded in the production databases, and this isn't necessarily a bad thing. What was a bad thing was the thing table that was discovered. A six-way mapping table between different types of entities from completely different parts of business logic, including user roles, scheduling specifications, and assessment targets. These were not many-to-many relationships being maintained. No, my friends, this was a mapping table from one global thing ID to anything. A quick enterprise GitHub search for thing ID revealed the horror that had been unearthed. Almost every interaction in the company first queried this table to work out what on earth it was supposed to be doing with the given thing, and caused DataGrip to spew out this entity relationship diagram such as it is. It's easy to discount this as lazy engineering or an incorrect abstraction, but on research, there were three things that they don't necessarily justify leaving it that way, but they do explain the history of how things can end up this way. Factor one. Long ago, there was no thing table. The company data architecture was originally built quite cleanly, and there was no need for such hellishness. Point two. long ago, certain database applications, the performance characteristics were different. Foreign key performance particularly wasn't great for doing multi-entity one-to-many relationships, and it wasn't all that fast. This was genuinely a decent approach. And then also long ago, it was recognized that the company could expand some of its capabilities by acquiring a few other companies and integrating their data pipelines into theirs. Now, I think we can see the trouble. Long story short, an engineering division was under pressure to deliver on grand promises and hack together a solution that reused existing clean data architectures in several different ways at once. So, Exhibit B, a rule by any other name. Your intrepid data scientist was looking to deploy a data pipeline to automate something that had previously just been a script running on a cron job on somebody's laptop that just been running for ages. While they were upskilling in AWS, identity management appeared to be a massive pain in the backside. So it was decided to reuse an existing execution rule called API ingest RO. And considering this was largely an ingest project, that made sense. The decision was reviewed with direct superiors and they saw no problem with it. On deployment, the global pipeline instantly died as the entire company's client base started routing traffic through this completely inadequate pipeline instead of the primary ingest nodes. This isn't really the story of a hack, it's a story of subjectivity. One person's ingest is another person's, well, you know. In this case, the rule was not originally intended, as had been assumed, for API clients trying to read data from our own systems. Rather, it was the complete inverse. It was intended for accepting data from external API clients, sending data into our own systems. Unfortunately, this intention was not documented anywhere. The hack was frankly a clever piece of early cloud load balancing where traffic was routed around the places that responded fastest with the least amount of non-200 responses. And guess what our intrepid data scientist's pipeline actually did? So yeah, we can see what went wrong there. Okay, so third and final example. What's the difference anyway? In another life, our friendly neighborhood data scientist was doing a comparative analysis between participants in two different groups that were put under different kinds of stimulation, and the question was, what was the quantitative difference in response between the two groups? Our data scientist took the measurements, assessed the difference between the groups, and delivered the following two messages to the marketing team. Group B responded 25% more than Group A. Group B's response increased by 5% on average compared to Group A. Time passes, the report is published, and then the calls start. Your numbers don't make any sense. How can you have such a substantial effect? It's physically impossible for a person to respond that much. You must just be making it up. Data scientist goes to the website to actually read the completed report for the first time. This product increases response by 25%. The observant among you will notice that this is not true, and this was not included in any of the data that was given to the marketing team. But we can laugh about this now, but really this is a story of crunch timelines with a priority for speed over clarity and with no opportunity for review or feedback for subject matter experts. Our data scientists gave two factual comments on the data from deep in their own trenches. Through that snippet of knowledge over to the no man's land into the editing trenches, and this was then rushed out the door with little to no final review. And by the time the honest misinterpretation was revealed, it was clear that both sides had screwed up. So it's been easy to stand in conferences like this for years as an individual contributor, a startup data scientist or solo researcher, and wax lyrical about how all the things that other people do is crap and it'd all be better if everyone was just listening to me. And it's also an awful lot of fun. However, how do you actually kind of curate the kind of culture that solves these kind of problems? Both within your team and also within the people that you're having to deal with, your engineering division. Of course, your data science team is within your engineering division, right? But then further afield, within the company, within the wider data ecosystem that you're living in. Well, for my sins, I've been doing this for a year and I don't think I've succeeded yet. But here's some of the things that we've been doing in my team to try and foster a culture that removes the possibility of these problems appearing. As we've seen, one of the most challenging parts of a data scientist's job is often interpreting and ingesting from something that was never designed to be accessed in weird and wonderful ways that they want to. data science has to have a seat at the engineering architecture table as well as the marketing table sometimes, both to manage expectations and to highlight premature abstractions or constraints that might later cause a massive headache for analysis, but are really simple to think about and reason on early on. Transparency. Teams are encouraged to share both their successes and failures in open with the rest of the company, and encouraged to discuss their work in progress openly with other teams in our team's private or open public Slack, and bring in subject matter experts from across the company to contribute to the discussion. That way we can test our assumptions early and often, so whether you're a greenhorn statistician or a distinguished engineer, you can ask stupid questions without any fear of backlash, because we're all learning. Another one that I think is important, but unfortunately I would class as being one of my failures in this regard, is in diversity, where I started off being given a pair of extremely experienced engineers who knew the platform inside and out, but not so much on the analytical rigor or the statistical operations. My first attempt at hire was a talented neurobiologist. Unfortunately, this was rejected above my head as they didn't have enough programming experience. My internal response was, yeah, doy, that's kind of why I wanted them. But I ended up hiring a statistician who'd done some R and some Python and then proceeded to beat the R out of them. But anyway, back to the point. Data science is a field that thrives on questioning and challenging coming from different perspectives. And if all you have is one leg, you're going to fall over. And I haven't been quite sure how to define this term, but so I've come up with defended empowerment. Part of my responsibility as a team lead is to give my team cover, both from management noise, but also from vexatious questions. Our team is able to do great things because of the deep and wide knowledge that's embodied in it. And I don't want to waste that strength having them fielding questions from colleagues who haven't read our reports or done any of their own research. So I field those calls. And if I can't point to a part of a report or a document or a code that explains the question, I add it to my own to-do list to explain it and update the documentation, and then get the original contributor to review my changes. So in a nutshell, that's it. That's my principles for trying to establish a high-performing data science team. Get good, diverse people, encourage their curiosity by giving them the freedom to talk to anyone, and encourage them to share their successes and failures and cover their ass from all the stuff that gets in the way, and make sure that their voice is heard at the highest levels as an equal partner. But that's not really why an awful lot of people come to these talks, so we'll go for the fun one. So this is my current recommended stack. I've moved away from self-hosting Jupyter because I'm trying to avoid doing system administration. So Jupyter stacks, really, really easy, just, literally just Docker up, blah, blah, blah. We're actually also looking at migrating from locally or hosted on our own premises containerized stacks to moving to Azure Databricks and having all of the environments based in our GitHub Enterprise environment. And it's actually looking really good at the minute. I'm hoping that next time around I'll be able to share more about that one. Another one that I learned about was in the middle of that slide. Metabase is fantastic for exploratory data analysis and also being able to annotate data as a team. Quite often people look at annotation from, I'm going to make a mind map, but Metabase is fantastic for being able to literally tag elements in a schema and go, this is something that's weird, or adding in certain abstracted queries that you can then use for prototyping dashboards and things like that. And then you are able to still get the raw SQL out that if you want to automate stuff later on. JetBrains, DataGrip, the whole JetBrains suite, I'm a sucker for them. So DataGrip for SQL or any kind of realistic data store, PyCharm for my own preferred development environment, and Golang whenever I have to. Also, this is more of an architectural thing than anything else. If you're doing data science, you need to have a data catalog and a data glossary. So data glossary tells you what words mean. That needs to be agreed with PM at least. And data catalog is actually a metadata store for being able to have a single point of contact where you can go try and find it in this list of things, and then it will route you. So you're not necessarily throwing everything into one repository, but you have one signposting avenue. We've been using Azure for this. AWS Glue does something fairly similar, although I think it's more internally focused. And then NB Conflux, I'm an absolute sucker for because, frankly, if you just make your reports in LaTeX and PDF, no one is ever going to read them. So take your Jupyter notebooks and actually compile them into Confluence pages so that other people can read them. And to make that slightly easier and have more interactive graphs, we use Plotly Express. If you haven't looked at Plotly Express recently, go for it. It's a much easier API for doing pretty graphs. So that's it. Data science, in my mind, sits somewhere between engineering, R&D, and management. Most people think it's either magic or going to steal their jobs, or both. And for all the talk of data science being about technology, so far recently, I've had to learn more about the human side.